The steel tendons inside a concrete flyover are kept in extreme tension. If this tension is low, this may happen after a few months of operation. Normal concrete flyovers produce tensile stress along its bottom fiber, and concrete is very bad at handling tensile stress. When you keep the steel tendons in tension, and when they're not allowed to go back to their original length, the concrete gets compressed. Before the flyover work is over, if we can compress the concrete like this, it will develop much less tensile stress due to the live loading. In short, the flyover will last decades without developing cracks. These powerful hydraulic jacks do the difficult job of tensioning the steel tendons. The high-pressure fluid moves the piston and the cables get tightened. After tensioning the cable, the workers release the pressure, remove the machine, and cut off the extra wire. Then why don't these cables, which are in high tension, contract and go back to their original length? To understand this logically, we 3D printed a simplified model of the hydraulic jack and the entire post-stressing mechanism using a Bamboo Lab printer. These simple wedges do the tricky job of keeping the tensioned cables in place even after the hydraulic jack is removed. When the block moves like this, the block will close the gaps in the wedges, and the wedges will form a strong connection with the tendon wire. In the second case, when somebody is pulling the cable from the right, the wedges won't form any strong connection with the tendon, and the tendon wire will stretch toward the right freely. When the jack moves from left to right, the outer wedges are tightened, and the cable stretches from left to right. It's undergoing a tension operation. The inner wedges cannot block this cable movement, since these wedges are not getting tight with the cable. After achieving sufficient tension in the cable, the engineers release the pressure on the piston. Here, obviously, the cable wants to retract inward. However, as soon as it moves a little, the inner wedges will get tight with the cable, and further motion of the cable will be arrested. In short, these wedges will ensure that the cables remain in tension forever. What a clever engineering feat to keep the cables always in tension. Simplicity at its best. Please check out Bamboo Lab's website and check out their user-friendly and accurate 3D printer models.